All right, guys, good morning. Happy Thursday. Today's day 3 of isolation, and we are working on these smart graphs. I have not done one, and I do have to apologize because I told you I'd have this video up yesterday. The day got away from us. Me and the kids got busy, and it did not happen. So I apologize for that. Okay, so today we're doing these smart graphs. So I will do this one with you, which is the Hurricane Katrina one. You should be able to do the rest. You need to have either a Google Doc open, ready to go, titled Smart Graphs, and then you need a piece of blank paper. Title it Smart Graphs. I got some allergies, so sorry, I apologize. Put my water next to my pen. Okay. So Hurricane Katrina, the hurricane that hit New Orleans in August 2005, was the deadliest and most destructive Atlantic hurricane of that year, and the 6th worst since the start of record keeping. It killed over 1,800 people and caused over $80 billion in property damage. More than 1 million people left New Orleans as a result of the storm, and many have never returned. In this activity, you will use graphs to understand the Hurricane Katrina. So then you're going to click down here and click Next. Okay, now you're going to work through all these graphs, and you can actually do them and answer them. Hello. Okay, well, maybe it's because I started it and then I exited out. All right, well, here we go. Let's do a refresh. I love technology, it's the best. Look at my water, please. Thank you. All right, I apologize, y'all. While we're waiting, tomorrow's activity is going to be super cinch. You will not need a video for tomorrow. I usually show tomorrow's activity when we get to evolution, so we just won't do that this year. Okay, let's try again. All right, if I hit next, please show a graph. Please show a graph. Yay! Hang on, Crosby. Okay, this graph shows the progress of the storm over approximately a week. The vertical axis shows... Okay, come here. Hey, get him. The vertical axis shows the distance of Katrina from New Orleans in miles, and the horizontal axis shows the time by date, starting on August 23rd and running through August 31st. On the graph's x-axis, 23 represents 12 a.m. midnight on August 23rd, 2005. Halfway between 23 and 24, where the first blue dot is shown on the graph, is 12 p.m. noon on the same day. So here we have 20. This is noon. So this line is midnight. This is noon, and this is midnight of the next day. Okay? Okay. So, every day starts at midnight. So look at the graph. When did Katrina hit New Orleans? Tap this point on the graph. Okay, so if you look at the graph, we have all the dates and how far away it is from New Orleans. So here it's the furthest away. So when did it hit New Orleans? So obviously this is whenever it's so close, right? Like it's 0 miles away. So that's the best bet. So I'm going to click that. And then I'm going to click check my answer. Correct. Hurricane Katrina hit New Orleans when the distance from New Orleans was 0, or a little after 12 p.m. noon on August 23rd. So it hit at noon on August 29th, my bad. Okay, so let's go. You need to, on your piece of paper, on your Google Doc, you've titled it, what did you title it? Oh, Smart Graphs. And then you're going to have a subtitle of Hurricane Katrina, and then you can just do number 1 is August 29th at noon. I'll write that down. If you need to pause while you get that written down. All right, wind speed. You just identified that Katrina hit New Orleans at 12 p.m. on August 29th, 2005, or 29.5 on the x-axis. This graph to the right shows the wind speed in miles per hour with the time in hours, starting at 12 a.m. on August 23rd and running through 12 p.m. on August 31st. On the graph's x-axis, 23 represents 12 a.m. midnight on August 23rd, 2005. Halfway between 23 and 24, where the first blue dot is shown on the graph, is 12 p.m. noon on the same day. Okay, so it's the same, guys. So the difference is the time of day, or the difference is now we're looking at speed. So starting on the 27th, which we know it didn't hit initially until 29th at noon. The 27th is when the wind started to increase. So the question is, tap the point on the graph that represents the wind speed when Katrina hit New Orleans. So when did it hit New Orleans? Well, it hit New Orleans on the 29th at noon. So this was the wind speed.
Mom, can you turn on?
I'm going to check my answer. Hang on. Okay, the wind speed was about 89 miles per hour when Katrina made landfall at New Orleans. That's almost 30 miles per hour over the speed limit on most major highways. Yeah, that's insane. So if you look across, we're between 88 and 90 miles per hour of wind. Okay, so on number 2 for Hurricane Katrina on your paper, you will write 89 miles per hour, because that's what it tells you right here. What, buddy? Hang on, bud. You went down?
Yeah.
Hey, Cammy, come get your brother. Okay. So here are the 2 graphs of the distance to New Orleans and the wind speed. All right, so we have distance from New Orleans and the wind speed. So now the first 2 graphs that we already looked at, we're going to compare them. So what do you notice about them? So you can compare the 2 graphs. So when we say compare, that means how are they alike, or how do they coincide? Like when this happens on this is happening on this. So did the maximum wind speed coincide with the time when the hurricane was over New Orleans? If not, which came first? Did the maximum wind speed coincide with the time when the hurricane was over? Okay. So was max speed when it hit? Actually, no, it was like 2 miles per hour less than the max speed when it was right over New Orleans. It was at its highest when it was 200 miles away, which is super interesting. Okay, so that's what you're gonna write. You're gonna write, I'm gonna do this with one hand. So max speed was actually when the hurricane was, I didn't know I had caps locks on, 200 miles away, and it was coming and going, when the when the hurricane, wow, it was actually 2 miles per hour slower. Okay, so that's all the question asked. Now, what I would say also, if like comparing, obviously, the closer it gets, the higher the wind speed. That's just a general observation comparing these two graphs. Okay, so let's go to next, because you can't check your answer. So click next. Wind speed and landfall. Oh no. I have no, oh here it is. Okay. So you may have noticed on the previous page that the maximum wind speed was just before and again just after Katrina hit New Orleans, but that the speeds decreased slightly at landfall. Because hurricanes are driven by warm, humid air, usually found over tropical oceans, they lose energy when they touch land. As Katrina hits New Orleans and the coast of New Orleans, it hit cooler air and lost speed. On the bottom right image, red represents high speed, greater than 156 miles per hour, and the blue represents low wind speed, less than 39 miles an hour. Okay. So that's interesting. So you see whenever it hit right here, it started to slow down. It's cool air. Then it started to warm back up. And then it started to cool back down. Obviously, this makes a lot of sense because it's inland, which there's really not tropical weather in inland, which is very close actually. Here's Illinois. So we did get a lot of rain afterwards. Okay, touch of it anyway. All right, so barometric pressure. This graph shows the barometric pressure of Katrina. Barometric pressure is also called atmospheric pressure. The barometric pressure at the center of the storm is given in units called millibars. Normal pressure is about 1,000 millibars, but the pressure inside hurricanes is much lower. The horizontal axis shows the date, starting at 12 a.m. on August 23rd and running through 12 p.m. on August 31st. On the graph's x-axis, 23 represents 12 a.m. midnight on August 23rd, 2005. Halfway between 23 and 24, where the first blue dot is shown on the graph, is 12 p.m. on the same day. Okay. So here's the pressure. So remember, when did the hurricane hit? The hurricane hit here. So what was happening to the pressure? Pressure started increasing again because what did it say about the inside of a hurricane? It's the lowest pressure, so that makes sense. So here, right before it hits, we're at the lowest pressure. Then once it hits and starts to leave, the pressure starts going back up. So it says, when was the barometric pressure lowest? Tap the graph. Okay, lowest here. Check my answer. Correct. The barometric pressure at the center was lowest 12 a.m. on August 29th when it was about 901 millibars. Okay, so write that down on your paper or in your Google Doc. 901 millibars on August 29th at 12 a.m. Both information matter because if you're looking at the graph, it's measuring the pressure and comparing it to the date and time when the hurricane hit. Okay, so here are the two graphs as barometric pressure and wind speed. Did the moment of maximum wind speed coincide with the barometric pressure minimum? All right, so did the moment of maximum wind speed coincide with barometric pressure minimum? Okay, highest wind speed here and here. Does this go with the lowest pressure point? Yes, it does. Did the moment of maximum wind speed coincide with the barometric pressure minimum? If not, which came first? Well, it did. Let me take off caps locks. Caps lock. Okay, yes. Max. What the hell? Max wind speed was the same time as, wow. This is what I get for typing with one hand and looking down. As the lowest pressure. Other than the second high pressure point. So the second high pressure point, or high wind point, I mean, was actually not even close to the lowest pressure point. So that's interesting. Okay, let's click next. Make sure you got that written down. Barometric pressure and wind speed. On the previous page, you may have noticed that the minimum barometric pressure occurred at the same time as the highest wind speed, right before Katrina hit New Orleans. Every hurricane has an eye, which is the very center of a hurricane, and the lowest barometric pressure. Inside the space, the wind speed decreases, and sometimes there's no wind at all. Outside of the center, however, the winds can be very strong. The lower the pressure in the eye, the bigger the hurricane, and the stronger the winds outside of the eye. Wow. This picture to the right shows the eye of a hurricane from the weather plane inside the hurricane. Wow. So here's the eye. You see it? So this is where the lowest pressure and the lowest wind is. So right when it's right over you is actually the best part of it. Then as it comes and goes, it's the worst pressure and the highest winds. So next, let's think Hurricane Sandy. In the fall of 2012, Hurricane Sandy hit the East Coast, causing millions of dollars of damage in Pennsylvania, New Jersey, New York, and New England. The storm flooded major cities, cut powers to millions, and tore apart densely populated coastlines. The image to the right shows flooding in Seaside Heights, New Jersey. That's so sad. Okay, so if you were to look at the graph of wind speed and distance to shore for Hurricane Sandy, when would you expect to find the maximum wind speed, and what would it tell you? Okay, so when would we find the maximum wind speed? I really wish we had question and answer on this video. Okay, maximum wind speed would be, hopefully you've already come up with it, right before and right after the eye of the hurricane goes through the city. Okay, so max wind speed would be right before and right after the eye of the hurricane went over. I guess each city, because it didn't tell us exactly which city. Okay, and what would it tell you? What does it tell you? Remember, what does the eye tell us? The lowest pressure, the lower the pressure. Oh, I didn't go very good. Remember, the lower the pressure, what do we know? The bigger the hurricane. And especially the pressure in the eye, the lower the pressure at the eye. Okay, that's what we know. All right, let's go to next. This is our last slide. Oh, congratulations, you've reached the end of the reactivity. You have learned that hurricanes usually slow down over land where the air is cooler and drier. You have identified, which is something we should have added on the last slide, that the wind slows down, darn it, and the air is cooler and drier. You have identified maxima and minima and matched them to a meaning. You related changes in barometric pressure and wind speed to a hurricane's distance from shore. Good work. The image to the right shows boats that were tossed on Louisiana shore by Hurricane Katrina. Okay, so you are going to close out of this one, and then you are going to, on your Google Doc or on your Google, on your blank piece of paper, so you have 1 through, I didn't keep track of how many questions there were, but there were some slides without questions, even though there were 10 slides. So I hope you had all those written down. So you're going to go to the next one, whatever one you choose. Let's go to this one. And then on your paper, you're on the same paper, you're just going to put a subtitle. And you're going to subtitle independent and dependent variables. Wow, you guys had a lot of questions about this one, so maybe this will help you. So subtitle it, and then you're going to number underneath it and go through this and answer the questions. I'm not going to go through and give you answers. I feel like you can do it. Okay? There are 5 of these. So this might be your busiest day. If you need to break these up with another day, go ahead, because tomorrow will be easy. Tomorrow is this, watch the video when whales had legs. When finished, write a 1-paragraph summary about that. So 1 paragraph to me is 6 to 8 sentences, complete sentences with good punctuation, and I's are capitalized. And the paragraph is indented, okay? So my daughter actually just wrote 3 paragraphs yesterday on an opinion on whether smart cars delivering pizza is a good idea. And she had no trouble. She's in 4th grade. So I think that you guys can do this. So I'm not going to make a video tomorrow unless it's just to see my face. And then you guys have a break for the weekend. So maybe if you only do 2 or 3 of these today, which I only did 1, so if you do 2 more, watch the video tomorrow, and then do 2 more of those smart graphs on Saturday. Do 1 on Saturday, 1 on Sunday, or maybe skip this and do this on the weekend and finish this tomorrow. Whatever works for you. Monday we'll start strong with some more videos, but I'll try to connect with you over the weekend just to say hi. I hope everything's going good. I hope you are staying within your yard parameters and staying away from other kids. I know this is so hard. My kids already want play dates and they want to hang out with their friends too, but it's really pertinent that we don't do that, okay? Illinois' numbers jumped from 55 to 128 in 1 day. Now, mind you, a lot of those numbers are in nursing homes where everyone's confined together. So they had, I think, 20 cases, new cases in a nursing home, including 2 or 4 people that worked there. I forget the number. So that just goes to show that it's how highly contagious it is. Even the nursing home, they're probably delivering foods to bedrooms. They're probably not leaving their rooms, and still the contact to the workers, from the workers to the other residents, it's very contagious. So I know this video is very long, but I just I wanted to work through that whole one with you. I wanted to tell you about tomorrow, and I wanted to give you an update on Illinois. So anyway, please be mindful of what you're doing. Make sure you're cleaning, washing hands, helping your parents, being a good child, and I hope to see you soon. Talk to you later. Bye.